Hello friends, we just got done going over some of our properties of equalities and properties of congruence, and we're about to dive into proofs. But before we do that, we need to talk about one other area of proofs that kind of seems weird, and that's going to pop up and that we should know about. And it's this word definitions. And it is a reason that we can use in proofs that happens quite often, but it seems squirrely, it seems strange. It happens whenever in a given, we're given a word or a symbol that we can then define to our advantage. And I will show you that directly below this in an example. But here are some words I've listed out and some symbols that we know what they mean, and we can go ahead and use them to our advantage. So, for instance, angle bisector. If I tell you that something is an angle bisector, we know that it cuts an angle in half. So we know that two angles are now equal, and we're able to write about that in a proof. Or if we know that there's a segment bisector, we know that now a segment's been cut in half. And we can write about that. Or a midpoint, been cut in half. Now we have got two equal things. Perpendicular means 90 degrees. So these words have meaning, and because of their definition, we can write about them. So what that means is that when we have our proof, so we've got our proof, and it has on one side statements, and then on the other side, reasons. If we write out a statement that is a direct result of a word or a symbol in our given, then we're going to write as a reason definition of, and then we use the word that we defined. If it's definition of angle bisector, we'll write that in there. Okay? That's what we do. We tell them which word we defined. Okay? So let's go ahead and look at an exact example of that down below here. Okay? So we're going to prove vertical angles. We're going to show beyond a shadow of a doubt that vertical angles are equal. Okay? So a theorem is a conjecture that's proven. We're going to prove that vertical angles, that theorem is proven beyond a shadow of doubt at all times. So here's our given. Angle 1 and angle 2 are vertical angles. There we go. Those are vertical angles. And now we're going to prove that they are congruent. So our first statement, we always write it out, angle 1 and angle 2 are vertical. Oh, goodness gracious, that's not the right way. Are vertical angles. There we go. And my reason is because that's the information that we're given. Okay? And at this point, we've just named them that. They're vertical angles because we decided that angles that are across from each other are called vertical angles. Okay? We've just called them that. They don't have any power, nothing beyond the fact that angles that are across from each other when two lines intersect are called vertical. Okay. Now, when I do this, whenever I look at a proof, it can seem really overwhelming to look at this. This can seem overwhelming. Okay? So what I want you to do is stop thinking about that and start looking in at this, just like you would the algebra problems we looked at ahead, and think, how do I know that these are equal? How can I prove it? What would I do? Let's see here. Well, what do I know for sure? What things do I know? Remember when we talked about assumptions, we talked about that we can assume straight lines, right? We can assume straight lines. So we do know that like that one and that one, 1 and 3 together equal 180. Okay, yeah, we can prove that. And we can prove that those together equal 180. You know, sometimes I even throw in numbers, like, if I said that this one was 100 degrees, how much would this one be? Well, that would have to be 80, right? Because those together would have to be 180 because they're on a straight line, right? Yep. And then this is a straight line, which means that this must be 100 because those two make up a straight line, right? Oh, which means these must be equal. Okay, so I've proven it with numbers. Can I prove that without numbers? I'm going to do the same thing. I'm going to say, what if angle 1 plus angle 3 equals 180 degrees? Okay, yeah. And angle 2 plus angle 3 must equal 180 degrees. Yeah, that's got the ticket. That's where I'm headed. I have to think through this, okay? And know where I'm headed. So I've got that. That's what I'm going to put down here. I'm going to do that. I'm going to write angle 1 plus angle 2. And, oh, remember, when we're doing geometry here, it has to be the measure in front of there. The measure of angle 1 plus the measure of angle 2. Okay, measure of angle 1 plus measure of angle 2 equals 180 degrees. And they left us a little extra space, so we're going to put both of them in there at the same time. Measure of angle 2 plus the measure of angle... Oh, I put the wrong numbers in there, didn't I? Mrs. Cruz, pay attention. Angle 3, there we go. Plus the measure of angle 3 equals 180. Okay. Now, what's our reason here? Well, let's see. That's because they're a linear pair. Yep. That would be segment addition. Segment addition. There we go. Or not segment. Oh, angle addition. My words, angle addition. There we go. Angle addition. Okay. Now, if we look at these two, if both of these are equal to 180 degrees, that kind of reminds me of that transitive property where if we've got A equals B and B equals C, then we can set A equal to C. That's transitive. So we could do transitive property, or we had another one that said X equals Y and X equals Z. Therefore, Y equals Z. I can't remember how we wrote it, but we could do the substitution one where we just substitute too. So you can use either transitive or substitution. I have to go back up and look at exactly how I wrote that substitution one. We're both looking right back up. Here we go. If X equals Y and X equals Z, then Y equals Z. Yes. There we go. So ours actually looks a little bit more like substitution right now, just the way it's written out, because the 180 is on the same side. It really probably doesn't matter. We could probably go with either one. I don't think Alex would yell at us for this one. So we're going to go the measure of angle 1 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 3. The point is that since they're both equal to 180, we can set this and this equal to themselves there. Okay. All right. And then that's because of either transitive or we could say substitution. There we go. Now what? Now we're going to get rid of, we want to get to this. Whenever you get stuck, sit there and look back up at proof and say, what do I want to get to? Okay, I want to get to 1 being equal to 2. And currently, I have 1 and 2 on each side. So we're really getting close. We're getting close. We've got this extra 3 on each side we need to get rid of. So what I want to do is I want to subtract my measure of angle 3 from both sides. So I end up with measure of angle 1 equals the measure of angle 2 by subtraction. Yay, we're getting so close. Now we take a look. Is this the same thing as that? Not quite. I need to make it from equals to congruent. Equals to congruent, okay? So I can do that by doing this. Angle 1 is congruent to angle 2. And how I do that, whenever I have a change from equals to congruent, that's a symbol change. And I can do that by the definition of congruence. The definition of congruence tells me that they are in essence the same thing. And that's my proof. By the way, this stuff in the purple, that is not necessary. It doesn't need to be there. I wrote it for you, but it is not necessary in your proof. Okay. Now we're going to do a couple more here. All right. Now we've got that B is the midpoint of segment AC. AB equals 15. Prove that BC is 15. Okay. So if we know that B is the midpoint of AC, I'm going to not look at my proof. I'm going to go over here and look. B is the midpoint of AC, so I'm going to mark up my diagram there. AB is 15. Then obviously BC is 15 also. So that's going to be pretty easy to prove, right? Okay. And this one is going to be very similar to what Alex gives us. They give us some fill in the blanks. That's nice. So first one, B is the midpoint of AC, AB equals 15. The reason is given. Hey, that's nice. Cool. Next one, AB equals BC. How do we know that AB is equal to BC? Why did we know that? What told us that AB was equal to BC? What in here? It was that word right there. That word midpoint. I'm trying to erase that. There we go. Midpoint. And whenever we have a word that tells us, then we need to use definition of midpoint. And finally, statement. Okay. All right, now it tells us our next reason is going to be substitution property of equality. We're going to substitute something. We're going to substitute in, well, if we know that AB is equal to 15, we can substitute 15 in for AB. So we're going to put in 15 equals BC. Ooh, there we go. That's mighty close, but it's not quite exactly perfect. So actually, our proof is not done. We're going to give ourselves one more line. And we are going to flip these and make it BC equals 15, which is our symmetric property of equality. There we go. Okay. All right, let's try one more. All right, given BD is the angle bisector of ABC. Okay, so BD is the angle bisector of ABC. So that means this one and this one are the same. And ABD is 65 degrees. So this one's going to be 65 also. Prove that ABC is 130. So we need to prove that the whole thing is 130 degrees. Okay. So we're going to come over here, and the first thing we need to do is put in our statement. Well, that would be all of this. Paste that up there. Smarter, not harder, right? Okay. Secondly, they say angle CBD must be congruent to angle ABD. How do we know that? How do we know that this one was congruent to this one? We knew that because of that word, that exact word. So we're going to write the definition of angle bisector. And then we moved from this one down to here. And what did we change? We changed our congruent to equal. We went from angle to measure of angle. When we do that, that is always a definition of congruence. Okay. And what did we do when we went from this line to this line? We changed this to this. How did we know we were able to do that? Right up here. The measure of ABD is 65. So we can substitution. We're able to substitute 65 degrees in for ABD. Okay, so now what they've done so far with the proof, they have proven that these are both the same and that this one is 65 degrees. Okay, now they've written out this this line that says the two angles added together equals the whole angle. CBD plus ABD equals ABC. That's angle addition. And then there and there, they put in 65. They're able to do that because they know that CBD is 65 and ABD is 65. They substituted again. Then they tell us that they're going to simplify, which means they are going to combine like terms. And then it does not perfectly match, so we are going to make one more line and rearrange. And that is our symmetric property. All right. Now go try an ALEKS 2. And don't forget, in ALEKS, if you get stuck, look off to the side and see if there's a button with a little person there, with the little things right there, and see if I've recorded a video doing some of the proofs. I may have helped you out in some of those proofs as well.